Hi guys, yep, it's me. Sorry I can't be with you today. I'm getting a root canal as we speak. And yeah, Bobby, I know. You would rather be getting a root canal than be in Algebra 2 class, I know. Anyway, today I'm going to do notes, hopefully through this video for you, on inverse functions. So let's go ahead and get started. You should all have a copy of the handout and you can follow along as I do the notes with you. So we're going to start with that definition of a function. A function is a relation in which each x value can have only one y value. And graphically that means that it passes the vertical line test. So what that means, to refresh your memory, is if we have a graph, let's say I have a graph of a parabola here that opens up. The vertical line test says if I take a vertical line and I pass it anywhere through my graph, and it only hits that graph in one point, then the graph is a function. Okay, I'm going to clear this. On the other hand, if I have a graph like a sideways parabola here that opens something like this, and now I take a vertical line and I pass it through different places on my graph. If I pass it through here, it only crosses my graph once, which you might think would make it a function, but as I move that vertical line along to the right, it starts hitting my graph in more than one point, and this means that it is not a function. NAF is not a function. Alright, so now that we kind of refreshed your memory about what a function is, let's talk about what an inverse function is. And an inverse function is a relation that switches y values back into x values. So it's something, an equation or a table or a graph that swaps the x's and y's. And there's a specific notation that we use that looks like this. Remember our f of x notation that represents y? Well, the inverse that undoes it has this little -1 power up here. And that little -1 is not a negative exponent. This is read as f inverse, that's what the little -1 up there means. F inverse of x just means that it's the opposite of f of x, and that is not a negative exponent, which means we're not going to be putting anything under 1. It means something different, and it all kind of depends on what kind of information we're dealing with. We're going to look at tables, graphs, and equations today. Alright, so first we're going to look at tables, and we've got a table here for the f function on the left that has inputs and outputs, x's and y's, or x's and f of x's. And to create an inverse for it, all we're going to do is swap the position of the x's and y's. So the row over here that are my y values are now going to become my x's in my inverse table. So my row is going to look like this: -2, 1, 2, 4, and 5. Notice I didn't change any signs. All I did was swap the position of that row. The y's now became the x's. And likewise, we're going to do the same thing with this row up here. The x's are now going to become the y's. So this row is going to look like this: -2, -1, 0, 1, and 3. And it's that simple. That's all you've got to do to create an inverse for a table. I know everybody can handle that, so we're not going to look at any other examples for tables. We're going to move on to graphs. Okay, so what I would like you to do is take a couple minutes here, and I want you guys to plot the ordered pairs for both tables, for both x and f of x, which are your x's and your y's. That's just ordered pairs. So for example, one ordered pair that I would plot from the first table is the ordered pair -2, -2. It's an ordered pair. I just make a little dot over here at -2, -2 on my graph. Okay, so I'm going to give you guys a few minutes. I'm going to be working on that on my own here, and I'm going to do mine in 2 different colors. So if you have 2 different colors, you can do that on yours also. Alright, so hopefully when you plotted all your points and connected the dots, your 2 graphs looked like mine. The one in red is for the f of x function, that's the table on the left. And the blue function is the f inverse function that is taking all of those points and plotting them on the from the right side table. So hopefully you notice that these 2 graphs have the same shape. So that's one of the graphical relationships that we see, that the shape is the same. And the other thing that we did, of course, to graph these is that we swapped the ordered pairs. And then the last thing that I want you guys to notice, we do notice symmetry. And the symmetry is across a special line. It's across a line that goes up through the origin at kind of a 1-to-1 slope, and this line has an equation of y equals x. So these 2 graphs, 2 inverse graphs, are symmetrical across the line y equals x. That's where all of the x values are the same as the y values. And that just comes from swapping the ordered pairs. So down below here we've got 3 graphs, and they want us to use the graphical relationship of inverse functions to draw the inverse of each graph below. 2 ways you can do it. You can work from the ordered pairs on the points that are given to you on the graph, or if you're a visual person and you understand how these points are being reflected perpendicularly across this line y equals x, you can do it that way. I'm going to do it by swapping ordered pairs. I'll show you one, and then I'm going to let you guys do the other 2 on your own. Alright, so the first graph in example A is kind of like a half a parabola almost, and it has these 3 ordered pairs that I have written off to the side, 0, 0, 1, 2, and 4, 4. Now, to graph the inverse, you guys know we can just swap the x and y position of the ordered pairs, and really that only affects that middle point. It's going to flip it around to 2, 1. And that's because the other 2 points, 0, 0, and 4, 4, those would be on that line y equals x. So they're not really going to move when we plot them. So watch what happens when I plot my inverse points and connect the dots. Okay, so I plotted the inverse points and notice that 2 of them stay in the same position. So when I connect them, the shape has to stay the same. It's got to stay that same kind of curve, but it's got to curve kind of the opposite direction through those points. So your graph looks something like the curve in red here, and that's our f inverse of x function with the little -1 power. Okay, so you guys try the other 2 here. You can do it the same way I did by swapping ordered pairs, and we'll see how you do here in just a few minutes. Alright, so when you graph the inverse of the graph in example B here, the points I have are plotted in red as the inverses where I swap the ordered pairs, and we have to connect them through with a straight line. So the blue line and the red line are inverses of each other. Let's see what happens with the very last graph in example C. So here, this one is a little tougher. It's a little trickier because all of the ordered pairs, 2, 2, 0, 0, negative 2, negative 2, if I were to swap the x and y position, I would end up with the same ordered pair. So this one is really one where you have to do a little visual inversing. You have to kind of picture it curving the opposite way. So the blue line curves down and in toward the x-axis at the origin. So it's got to curve the opposite way when we are graphing its inverse. It's got to do something like this. And curve to the, sorry guys, it's a little tricky sometimes with this, and curve down the opposite way. So it almost looks like a double helix. Okay, not perfect, but it's a rough sketch. And it looks something like that in the red graph for the inverse.